In the last video, we worked on building the physical garden, as well as the piping for the irrigation system. In this video, we'll be working on the electrical components and circuitry, the coding for it, as well as finishing touches of the garden. If you're watching this, you've probably seen part 1 of the project. If you haven't though, you should go check it out. For those that don't have the time or don't want to go back and watch the first one though, basically I'm making a self-watering garden that will reduce the waste of water from overwatering. Traditional gardens can be a great way to grow plants and vegetables in your backyard. All you need is a plot and some dirt. There's a problem though. Over half of this water that is used outside is wasted on inefficient watering methods. That's why my mission was to create a self-watering garden that minimized the waste by watering the plants with exactly how much water they need.
Since for my project to work, I had to have a solenoid valve opening at a specific time, I needed to find the correct electrical parts to do this task. I had chosen Arduino as the computer I would be programming with, and after some searching on the internet, I found that a relay module was the part that I would be looking for to open and close the solenoid valve. A relay module is an electrical component that enables electricity to be used at certain time intervals that you can program with the Arduino.
Right now I'm wiring the system that will make it so the solenoid valve will be able to close and shut electronically. And so first I have an Arduino Uno. I am wiring the ground and voltage pins to this module, as well as a general pin to the module. And what the relay module will be doing is it will be telling the solenoid when to open and close by using power from this 12-volt power supply. The relay is really one of the core components of this project, so I think it's important to understand what it's doing. The black and the brown pins on the relay are supplying the voltage and ground to it, while that white pin is connected to one of the general pins on the Arduino. Now, what this general pin is doing, you can see I have a solenoid pin as pin 12, is basically, it is reading the value of the solenoid pin. And this is effectively activating the relay. Now, when the relay gets activated, it means that this cable, right here, the purple one, that is usually sitting there dormant, gets power. Now, it doesn't get the power from the Arduino. It has a separate power supply that is connected right here. But this means that when the relay is turned on from the code, that it is able to turn on different electrical components, and in our case, the solenoid. So since the relay pin is 12 and solenoid pin is equal to 12, when I write digital write solenoid pin and then exclamation point digital read the solenoid pin, that is effectively turning on the relay. Now if I were to write that a second time, like you can see right there, that will turn off the relay. And this delay in between, if you enter a millisecond value between the brackets, will put a pause in between the two lines of code, so it has time to turn on, stay on, and then turn off. I ended up having to buy a new solenoid valve, as this one, when connected to power, would not activate. So right now I'm trying to connect the wires of the solenoid valve to the wires from the relay. And I came to the problem where it's hard to get them connect since they're different sized wires and I don't have a soldering iron to connect the two together. So what I'm instead doing is wrapping this around this wire a little bit, then putting some electrical tape around it, and I found that using these little clamps can also help. So here we can see it is connected pretty well because this thing's going to be outside, so it has to stay together. So now that I have the power to turn the relay on and off, I need something to be reading the soil to be telling when should the relay turn on and off. And for that, I'm using a moisture detector. Now the moisture detector works as a variable resistor. This means that these two probes measure the resistance in the soil. And when the soil is more wet, the resistance is lower.
The code that I have written right now, what it is doing is basically, it is saying to read the analog pin of moisture signal. Now that is the pin A1 right there. And that is getting the reading from the moisture detector. So it's saying, read that and then print out the value of it, where it's printing that in a serial plotter, giving us the value. So then there's a delay in between, so it's not like doing it too fast. Then it's going over to here. If the moisture is above a certain number, meaning if it's above a certain dryness, turn on the relay, because that's talking about the pin for the relay. Turn it on for 1 second and then turn it off. And then it's gonna go back up here and it's gonna check the moisture again and print out the value.
Here I'm putting the moisture sensor in a glass of water. This is to see if it will relay the information to the Arduino, telling it that it is in a moist environment. There, opening the relay and with that turning on the solenoid.
Where'd you guys
We
go?
went to Rudy's with Bear.
You did. Oh, okay. And then
So right now I have the moisture sensor in some moist soil. When I start up the code, it is going to read the moisture signal and display the moisture signal. You can see over here, it's around the number range of 260 right now. And the numbers basically mean the higher that number is, the less moisture is in the soil. Over here, I have an if statement. This statement says that if the moisture is above 485, to turn on the relay, opening the solenoid. The way I got the number 285 is by putting the moisture sensor in the dry soil and seeing the numbers that it gives me. I will demonstrate that right now. So just now, I put the moisture sensor in the dry soil, and we can already see that the number is way higher than before, around the 400s right now. Keep in mind, this was around 200. So when that number gets to 485, we will see the solenoid will open for 5 seconds, as the delay is measured in milliseconds, close for 3 seconds, this is to not overheat the solenoid, and then open again for 5 seconds. Now this really big delay right here, the point of that is to prevent overwatering. That's a 3-hour delay. That means after it's watered, even if the soil is dry, it's not going to get watered again for another 3 hours. This is because it's still good for the plant to be dry a little bit, but we just can't have it being overwatered. So right now, the value of the moisture in the dry soil is almost reaching the point where it would turn on the solenoid. So let's see if it reaches there and what would happen. So we can see it just hit that point. The solenoid just turned on, it's activated, the relay's activated, you can see. Turned off, that was 5 seconds. Now 3 seconds of downtime. On, back on for 5 seconds. Now, the plotter is not plotting any more values because it doesn't need to, as we're on the downtime of the delay. So now we'll be waiting, and when it starts monitoring the values again, the soil is going to be more moist from the watering it just got from the opening of the solenoid. And if it's not, then it will water it again. So here I've set up the electrical components for the garden in this shed. I have my power supplies right here, connected to an outlet. My Arduino is here, taped down. Relay, controller for the moisture sensor, and I have wires going out towards the garden. Now these wires are all little segments that I connected with pieces of tape like this to make one big wire that goes out to there. Out here at the garden, you can see the solenoid valve is connected to these wires as well that go inside, as well as my moisture sensor, which is in the soil. Again, leading back inside the window to the electronic parts in there. So right now we're gonna reset the timer on the Arduino, and we're gonna run outside really quickly, out of the soil, the moisture sensor out of the soil, and watch it do its thing. So here we go. And there are no plants in here yet. I'm gonna get some in there in a second. We're just gonna test this out right now. You can see it's filled up with water. Let's take it out. Give it a second to register that it's dry because it's in the air. And there it goes. Now it's gonna be closed. It's open again. And now it's open for 8 seconds again. And now it's off. And now the timer has started to count down for it to start again. So in the garden, I'm planting vegetables like basil and chives. These are vegetables that require high moisture levels in the soil.
And this garden will be good for providing these plants with the water they need consistently.
This is around 2 days after it's been assembled, and we can see that the soil is moist all around. I got some plants in there, and the tub of water is right here. I took the lid off to see how much is in there, and it's working. The plants are getting water. This one was dying a little bit ago. Now it's sprouting back
So
up.
one of the big reasons I'm making this video is because I wanted to show how you can identify a problem. In my case, it was the waste of water from overwatering gardens. And you can take it, and using engineering, you can work on ways to build systems to fix that problem. And that's what I did. And you can do this with a bunch of other, any problem you can think of. Engineering can be used to think of a solution. You just have to put your mind to it. So anyways, hope everyone enjoyed. I will be continuing to make projects on this YouTube channel. So share this with your friends and stay in tune for the next one.